Children, let us continue the chapter electricity. Now let us solve the numerical problems on combinations of resistances. Now the first question is, that is the example question given in the textbook 12.7. An electric lamp whose resistance is 20 ohm and a conductor of 4 ohm resistance are connected to a 6 volt battery. In the figure it is given. Calculate the total resistance of the circuit and the current through the circuit and the potential difference across the electric lamp and conductor. Now let us solve one by one. Here there are two components and the resistance of two components are given. One is a electric lamp with resistance 20 ohm and other one is conductor of resistance 4 ohm. Now let us consider these two are R1 and R2. So electric lamp, that is its resistance is R1 and conductor, its resistance is, let us consider, that is R2. So let us have R1 is equals to, that is 20 ohm, R2 is equals to 4 ohm and Rs we have to find out. Then here the volt is given, that is a potential difference of this voltage of the battery is 6V. That is the total potential difference across the two terminals of the battery is 6 volt. And here what you have to find out? The total resistance Rs and the current I. What you have to find out? Current I and the potential difference across the electric lamp and conductor. That you have to find out. That is the here V1 and V2. V1 is the potential difference across the lamp here, that is V1, and V2 is the potential difference across the conductor. Now let us solve one by one. Then first one we take, here the first question is total resistance of the circuit. So you take, that is A. So you know that Rs, because here this conductor and lamp are connected in series. So you take Rs is equals to R1 plus R2 in the case of series connection, and that is equals to R1 is, that you know, 20 ohm and R2 is 4 ohm. So it is 20 plus 4 is, that is Rs is equals to 24 ohms. Rs is equals to 24 ohm. Second, to find the current through the circuit, here the total potential difference across the two terminals of the battery is 6 volt. That is V is equals to 6 volt. And resistance, total resistance you got, that is Rs, R is equals to 24 ohm. And here we have to find out the current through the circuit. And according to Ohm's law, you know, I is equals to V by R. Here that is according to Ohm's law. So you know I is equals to V by R. Then V is 6 volt and R is 24 ohm. So therefore I is equals to, that is 6 divided by 24. 24 2s are 48. That is, here we have to put the decimal point, and here you will get 12, 0, 24 5s are 120. So it is 0.25 amps, 0.25 amperes. Next, C. What is that C? The potential difference across the electric lamp and conductor. Here we know the total potential difference across the two terminals of the battery, and the question C is find the potential difference across the electric lamp and also potential difference across the conductor. Now for the electric lamp you take, for electric lamp we have taken here. So let us consider here, that is R1. R1 is equals to 20 ohm and I you got, that is 0.25, and V1 you take. V1 is the potential difference across the lamp here. Then the formula for V. V is equals to, that is also according to Ohm's law, you can write V is equals to, what is that formula? IR. That is I into R1. V is equals to IR. V1 is equals to IR1. So that is equals to V1 is equals to I is here 0.25 ampere into R1 is 20 ohms. So that is V1 is equals to, that is 25 to the 50. It becomes 25, 20 the 500. So it is 5.00 volts. That is V1 is equals to 5 volts. Here the potential difference across the electric lamp is 5 volts. So you can write potential difference across lamp, electric lamp is 5 volt. Next, for conductor. So let us have, that is R2. R2 is here. You know that R2 is given. R2 is 4 ohms. R2 is 4 ohms. And the current is, as it is series connection, same current flows through the components. So I is equals to same, that is 25 amp, 0.25 amps here. And we have to find out V2, that is the potential difference across the conductor. Again we use the Ohm's law, that is V2 is equals to IR2. That is V2 is equals to same current 0.25 amperes into 4. You know that 25 4s are 100. So it is V2 is equals to 1.00 volts. That is 1 volt. 1 volt. Therefore, potential difference across the conductor is how much? That is 1 volt. You know the total volts is here 6 volts. That is 5 plus 1, 6. Here there are two questions in the chapter, that is in the middle of the chapter. First question is, draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2V each, a 5 ohm resistor, an 8 ohm resistor, and a 12 ohm resistor and a plug key all connected in series. Second question is, redraw the circuit of question 1, putting in an ammeter to measure the current through the resistors and a voltmeter to measure the potential difference across the 12 ohm resistor. What would be the readings in the ammeter and the voltmeter? So let us see the first question. Draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2V each, a 5 ohm resistor, 8 ohm resistor and 12 ohm resistor and a plug key all connected in series. So let us have the diagram here. See the schematic diagram of the circuit consisting of a battery of 6 volt, that is 3 cells of 2V, 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 that is 3 cells of 2V each here, and here there are 3 resistors of 5 ohm, 8 ohm and 12 ohm. Plug key is here, and all these components are connected in series. It is a series connection of the resistors, and it is a electric circuit that is consisting of a battery of 3 cells of 2V each and 3 resistors 5 ohm, 8 ohm and 12 ohm. Second question, redraw the circuit of question 1, putting in an ammeter to measure the current through the resistors and a voltmeter to measure the potential difference across the 12 ohm resistor. What would be the reading in the ammeter and the voltmeter? So the diagram will be, see the diagram here. Here the same diagram is redrawn here. Here there is a ammeter and the voltmeter is connected here, that is across the 12 ohm resistor. And what would be the reading in the ammeter and the voltmeter? To find the reading in ammeter and voltmeter, here total voltage is 2 plus 2 plus 2, that is V is equals to 2 plus 2 plus 2, that is 6 volt, and total resistance is, that is RS here. RS is equals to, that is the total resistance, is equals to 5 plus 8 plus 12, that is 25 ohm. Ammeter reading, that is I. Ammeter reading is nothing but the current flowing through the circuit. I is equals to, according to Ohm's law, that is V by R, and V is here 6 volt and resistance is 25 ohm. That is equals to 6 by 25 is equals to, again you know, that is 0.24 amperes here. If you divided 6 by 25, it becomes 25 2s are 50, 10 is remaining. Here it is 0.2, 25 4s are 100, so we'll get 24 amperes. So reading of ammeter reading is here 0.24 ampere, and voltmeter, that is V is equals to, you know that V is equals to I into R. I into R, that is the potential difference of the resistor of 12 ohms that you have to find out. That is here, you know that I is equals to 0.24 amps and resistor is, that is here 12 ohm. and V is equals to question mark. According to Ohm's law, V is equals to I into R. I is 0.24 amperes into R is 12 ohms here, and here the product of this 0.24 and 12 is 12 4s are 48, 4 carrying, 12 2s are 24, 4 28, and here it is 2.88 volts. So V is equals to 2.88 volts. So emitter reading is is 0.24 amps, and voltmeter reading is 2.88 volt. 2.88 volt. Now you see the example 12.8. The question is, in the circuit diagram given in figure, that is 12.10, the figure is shown here. Suppose the resistors R1, R2 and R3 have the values 5 ohm, 10 ohm, 30 ohm respectively, which have been connected to a battery of 12 volt. Calculate A, the current through each resistor, B, the total current in the circuit, C, the total circuit resistance. Here 3 resistors are there, and the resistances are 5 ohm, 10 ohm and 30 ohm. So let us have R1 is equals to 5 ohm, R2 is equals to 10 ohm and R3 is equals to 30 ohm. And here the potential difference, that is the battery of 12 is connected, means V is equals to 12V, and through R1 is also it is 12, through R2 also 12, and through R3 also it is 12. So by taking 12V and R1 5 and R2 10, R3 30, here we have to use the Ohm's law and we can find out the current through each resistor. So let us write here R1 is equals to 5 ohm, R2 is equals to 10 ohm and R3 is equals to 30 ohm. Then here V is equals to 12 volts. Now for first resistor, for R1, here I you can find out. For R1 is equals to 5 ohm and V is same, that is V is 12V, I is equals to question mark. According to Ohm's law, I is equals to V by R. So let us have, it is I1. So let us write I1 is equals to V by R1. That is V is here 12V and R1 is 5 ohms it is. And here it becomes I1 is equals to, that is 12 divided by 5. Know that 5 2s are 10. 2 is remaining here. So you put, that is 5 4s are. So it becomes 2.4 amperes. So I1 is equals to 2.4 ampere. That is current through the first resistor, that is of 5 ohm is 2.48. Next, for it is for R1. Next you take for R2. For R2 is equals to 10 ohm and V same here, V is 12V, and next I2 is equals to question mark, that is current through the second resistor of 10 ohm. Then you write the same formula. I is equals to V by R. That is I2 is equals to V by R2. And that is V is again same 12 and by 10, that is 12 volt by 10 ohm, that is equals to I2 is equals to 1.2 ampere. 1.2 ampere. Next for R3. For R3, here R3 is 30. R3 is 30 and V is same, that is 12V, and I3 is equals to question mark. Write the same formula according to Ohm's law, that is I is equals to V by R, that is I3 is equals to V by R3, and I3 is equals to V is 12 volt and R3 is 30 ohm, that is equals to, you know that 12V by 30 is equals to 0.4 ampere. So if you divide 12 by 30, you know that it is 0.0. 34 is 120. So you will get 0.4A. In this way, through the resistor R1, the current is 2.4A, and through the resistor R2, the current is 1.2A, and through the resistor R3, the current is 0.4A. Next, here we have to find the total current in the circuit. That is nothing but sum of all the current through R1, R2 and R3. So, next B is total current. Total current is equals to, that is total current in the circuit. I is equals to, so you know I is equals to I1 plus I2 plus I3. I1 is, that is 2.4 ampere. I2 is 1.2 ampere and I3 is 0.4 ampere, and totally it becomes 2.4 plus 1.2 plus 0.4 is, that is 4. Here if you add them, 2.4, 1.2 and 0.4, that is 4, becomes 4.0, that is 4 ampere. Total current in the circuit is 4 ampere. Next one is the total circuit resistance. Here there is a parallel connection, means you must take that 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Here R1 is equals to 5 ohm, R2 is equals to 10 ohm, R3 is equals to 30 ohm. So we have to find out Rp, as it is parallel connection. Total resistance is there, Rp. Then you know the relation 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3. That is equals to 1 by 5 plus 1 by 10 plus 1 by 30. Here the LCM is, that is 1 by Rp is equals to, the LCM is 30 here, and you know that 5 6 the 30, 1 6 the 6, 10 3 the 30, 1 3 the 3, 31 the 30, 1 1 the. So 1 by Rp is equals to, that is 6 plus 3 plus 1 is 10 by 30, that is 1 by Rp is equals to, you know that it becomes 1 by 3. 0 0 cancels here, 1 by 3. Therefore Rp is equals to 3 ohm. 1 by Rp is equals to 1 by 3. So Rp is equals to 3 ohm it is. So in this way you got the total current in the circuit and also total circuit resistance. Total resistance in the circuit. In the figure, R1 is equals to 10 ohm, R2 is equals to 40 ohms, R3 is equals to 30 ohms, R4 is equals to 20 ohms, R5 is equals to 60 ohms, and 12 volt battery is connected to the arrangement. Calculate the total resistance in the circuit and the total current flowing through the circuit. See the figure here. Here there is one arrangement. R1 and R2 are arranged in the parallel combination. So let us have, here it is Rp1 that you have to find out. And next here R3, R4, R5 are again they are arranged in the parallel combination, that is the system 2. So let us take, that is Rp2 it is. Next here Rp1 and Rp2 are connected in series. Rp1 and Rp2, the system 1 and system 2 are connected in series. Again we have to find out the Rp1 plus Rp2 as there is series connection. So you take Rp1 here. To find Rp1 you write R1 is equals to 10 ohm, R2 is equals to 40 ohm. As it is parallel combination, 1 by Rp1 is equals to 1 by R1 plus 1 by R2. That is 1 by Rp1 is equals to 1 by 10, it is R1 plus 1 by 40. So it is 1 by Rp1 is equals to, the LCM is 40, that is 10 4s are 40, so it is 4 plus 40 1s are, so 1 1s are, so you will get 5 by 40, that is 5 1s are, 5 8s are, 1 by Rp1 is equals to 1 by 8. Therefore Rp1 is equals to 8 it is. Rp1 is equals to 8. Now the second set of combination, that is Rp2. So to find Rp2 you take R3. R3 is equals to, here R3 is 30, R4 is 20, R5 is 60. R3 is 30 ohm, R4 is 20 ohm, and R5 is, that is 60 ohm. 60 ohms. Then 1 by Rp2 is equals to 1 by 30 plus 1 by 20 plus 1 by 60 it is. That is equals to, find the LCM of 30, 20, 60. 30, 20, 60 LCM. Know that 2 15s are, 2 10s are, 2 30s are. Again 2 5s are, 2 15s are, 3 5s are, then 5 1s are. So it is 5 3s are 15, 15 4s are 60 it is. LCM is 60 here. Then it is 32s are, so 1 2s are 2, 23s are, 1 3s are 3 plus 61s are. So it becomes 1 by Rp2 is equals to, that is 6 by 60, that is equals to 1 by 10 it is. 6 1s are 6 10s are. Therefore Rp2 is equals to 10 ohm it is. Here it is Rp1 is 8 ohm, Rp2 is 10 ohm, and these two combinations are system are connected in series. Therefore let us take RS it is, that is equals to Rp1 plus Rp2, that is 8 plus 10. 8 plus 10, that is equals to 18 ohm. 8 plus 10 is equals to 18 ohm. That is the total resistance. Total resistance in the circuit is equals to total resistance in the circuit is equals to 18 ohms. The next one is here the total current flowing through the circuit. Total current in the circuit. We know that I is equals to V by R. Here we have to find out. Know that here it is given that V is equals to, that is V is 12 volt. So you take V is equals to 12 volt and resistance R is equals to, that is 18 ohm, and find current flowing through the circuit, that is I is equals to question mark, and according to the Ohm's law I is equals to, that is I is equals to V by R. That is equals to V is here 12 volts and R is 18 volts, 18 amps, 18 ohm, it is 18 ohms. Then by dividing, that is 6 2s are 6 3s are, that becomes 2 by 3 amps. 2 by 3 amps. 2 by 3 means you can divide 2 by 3. 3 6 the 18, again 2 6 the 18, like this way, that is 0.66 amps. 0.66, and here 6 is recurring means you can write 0.67 amps here. 0.67 amperes of current flowing through the circuit.